Okay, here's our video for section 9.4. This is graph and solve quadratic inequalities. So we're dealing with inequalities here in this section. We're going to go through two examples or two different types of inequalities. First one is a quadratic inequality in two variables. So notice that we've got the variable y and the variable x, and we'll go through four different cases, right? We've got less than, we've got less than and equal to, we'll deal with greater than, and greater than and equal to. So the four different inequalities for a quadratic function, right? You notice x squared, this is standard form quadratic function, and we're dealing with variables x and y. That's why it's a inequality in two variables. If we set y equal to 0, then we're eliminating that variable y, and we'll deal with quadratic inequality in one variable. And notice we're, of course, going to go through all four possibilities. We've got less than, equal to. We're going to deal with greater than, and equal to. All right. So if we're dealing with graphing a quadratic inequality in two variables, we have to go through this three-step format. So step one is we're going to eliminate the inequality. We're going to just set the equation y equal to, and we are going to graph the parabola. And we're relying on a lot of our skills from earlier on in the chapter, especially, and maybe you want to refresh your memory, right? The axis of symmetry, it comes from negative b over 2a. So we might use that form. You know, you may go and try to find the x-intercepts. You've got different techniques to solve, or I should say graph this quadratic. Once the quadratic is graphed, we would make a dashed boundary line for less than or greater than, and we would use a solid boundary line for less than and equal to or greater than equal to. We then need a test point. We need to pick a point that's inside the parabola and determine if that point is part of the solution. So we would plug a test point back into the original inequality, and if it's satisfied, then we end up shading the region inside. If it doesn't satisfy the inequality, then we would shade outside. So let's go ahead and get into our first example. So here is what we need to do. We are solving, or we need to graph this inequality. So it's y less than and equal to, and notice right away our boundary line should be a solid line, not a dash, because of this equal to. This is a quadratic in standard form. Looks like a is negative, so it should be a parabola opening down. A is 1, so it should be, kind of that standard shape. It's neither skinnier nor wider. And so what we really need to do, and let me just check my notes real quick, we need to get into the axis of symmetry. I think it's going to be a helpful point. And this here this is going to be solid. Our boundary line is solid. So, just kind of going through the axis of symmetry is going to be negative 2 over 2 times negative 1, right? B is positive 2, and the formula for axis symmetry is negative b over 2a, and a is negative 1. So it looks like our axis symmetry is coming out as 1. How do I find the vertex? I plug 1 back into the original. Looks like I get 1 squared plus 2 times 1 plus 3. That looks like 4, if I got that found that correctly. So I'm going to go over 1, up 3, 4. Here's my vertex. I know that a is 1, so I should go over 1, down 1. I also can see that the y-intercept is 3. Again, not trivial graphing these parabolas, but again, the book is relying on the fact that you're very good at this from your previous work. Again, this parabola should be a solid line, for solid boundary. There we go. Not the greatest, I apologize, but you get the general shape. And now they were going to pick a test point, and they're picking 0, 0. 0, 0 is right here. And so if 0 into x into the original inequality and 0 into y for the original inequality, if that makes sense, if it works, then we're going to shade inside. So let's test it. Is 0, that's question mark, less than negative 0 squared plus 2 times 0 plus 3? So really what we're saying is 0 less than or equal to 3. And it is. So 0, 0 is a solution. And so I want to shade the area that has solutions, right? So I'm going to shade inside. And so finally here, if I come over and do a nice shading, right, this would be the solution, the parabola, and then shade the inside. I'd like you to try an example right now. So you've got a bit of an easier parabola to graph, right? You should see the axis symmetry here is 0. Easy to find the vertex. This parabola opens up, but really get into decide if you should have a solid or a dashed boundary line, and then figure out should you shade inside the parabola or outside. Go ahead and hit pause, and when you're ready, hit play. And here is the solution. So nice, I copied the book solution, which is the shading is spectacular, right? Better than my blue lines. You can see the parabola is opening up. We graphed x squared minus 2. The vertex sits here at 0, 2. The shape of this parabola with a being 1, I could just go over 1, up 1. You could go over 2, up 4, get nice shape, and a dash shape. Then you should test 0, 0. Nice inside. 0 is 0 greater than negative 2, and it is. So we're going to shade inside. Nice job. So check this out. We are now graphing a system of quadratic inequalities. So you're really doing two problems, and then you're looking for that overlap in the system. So I'm going to graph, first I'm going to graph x squared minus 2, which you just did in your example. Notice the scale here is by 2's. So I should be here and here for this parabola, right? And then nice kind of, oops, would not call that a nice graph, but not bad for a freehand. Right, and again, make sure you clearly show a dashed line. And so here, the test point would be 0, 0, and 0 is greater than negative 2. So I will shade inside this parabola, but I'm going to hold off, right? I'm going to hold off here so that I am going to do inside, and I want to kind of keep track of that. I think x squared minus 2. So the second parabola is trickier, and I already did some of the work here on my piece of paper. So I found the axis of symmetry to be negative 1.5, and then the vertex by plugging negative 1.5 back into the equation, I got 6 1/4. So not the greatest parabola to sketch, but I can work with it, right? So I'm going to go negative 1.5. I'm up 6, 4, 6, and a little bit more here, right? This parabola is facing down. The y-intercept here is at 0, 4. There's another point of symmetry over here. I'm going to get a solid line, right, because the inequality is less than and equal to. So I've got this second parabola that I graph over the top of the other one. And again, remember, for the dashed parabola, we were inside. Now let's figure out for this solid parabola, am I indeed going to be inside or outside? And if I plug 0 in, I get 0 less than equal to, looks like this goes to 0, that's 0, is 0 less than 4? And yes, indeed it is. So I will also graph inside the other parabola. And again, because I'm solving a system, the overlapping area would look like this, is inside of the two parabolas. And that is the solution. Pretty neat. Let's see if you can't do the same. So you've got two parabolas. Notice the first parabola should be pretty easy to graph. It's a parabola facing down, y-intercept of 3. Second parabola is going to be a little trickier. You're going to have I think your axis of symmetry comes out to negative 0.75, and plug that back in to find your vertex. Good luck, and here comes the answer. And there you go. So you've got, the first parabola was facing down. The boundary line is going to be a dashed line because just less than. The second parabola, I found the vertex to be at negative 0.75 and for x, and the y value to be negative 3.125. Kind of a drag, but we have to be able to graph these parabolas that don't come out to integers. And both of them are shaded inside. If you plug 0 into the second one, you get 0 is greater than negative 2, which satisfies it. And if you plug 0, 0 into the first one, you get 0 is less than 3. So the overlapping area is the solution, and that's inside. Okay, so we're on to the second part of this section, which is where we are going to solve a inequality in just one variable. Notice y has disappeared from the equation here. So you've got three techniques, and I wanted to show you the first two, but I'm going to have you just work with the third. So you can kind of sit back and relax if you want. You know, they're asking you to solve this inequality. It's kind of a crude method, but one worth talking about. You could set up a table of values. So notice for x, they set x to be integers from -5 to 2. And then you notice the y values here in red. And notice between -4 and -3, we switch from a positive or from 0 to a negative number and then back. And so to say, when basically are the values of x going to create, satisfy this inequality less than 4, you can see that it happens between 4 and 1. And again, you should be sitting back, well, what happened if it happened between -4 and 3? What if it was at -3.5? And so again, this system is a nice way to just identify, see the sign change, but we've got better methods. So another method to do it is graphing. So here, solving this inequality again, you're saying, hey, where is the parabola less than 0? And you can see on the graph right away, like here, when the graph is less than 0, you're down here, right? The parabola, anything above the x-axis, these values here, let's dash them, these are all positive y values, so that would not satisfy. Where do we figure out the transition? Check it out, quadratic formula, right? So we can solve for the x-intercepts and say that, any value for x that's going to be greater than 0.47, or any value of x that's less than the second intercept, -2.14, will satisfy this inequality. We'll set this inequality to be true. So again, nice to see, nice visual here on the graph. So here's our third way of solving, and this is the method I would like you to use. So let's see how they went through this guy. So first they say, look, set the inequality equal instead of, get rid of the greater than or equal to, and solve this, and solve it for the roots. We're very lucky, not very lucky, but we're luckier. This quadratic factors. If you didn't recognize that it factors, you could have used a quadratic formula. But so you get these two places where we transition, -4 and 3. And they call these critical x values. Oops, didn't mean to cross it out. Critical x values of the inequality. And so the key here is to draw a number line. And notice their number line is super fancy. I would draw, personally, a number line and just put the two values, -4 and 3. And that's it. You don't need a scale and all this other. I found it pretty impressive, but unnecessary. So what do? We put these guys, and then we need to test. We need to test a number that's less than 4. We need to test a number between -4 and 3, and we need to test a number bigger than 3. And so they tested -6, which is definitely in that region. And notice that they get that 30 is greater than 12, which is true, right? So this is, this area would work. And so from -4, this is a solution, is how you would draw that on the number line like they did, right? And then they tested 0, and notice 0 is not, nice symbol here, not greater than 12, so we would leave this empty. And then they tested 5, which is clearly bigger than 3, and they got 30 is greater than 12. So this again would be open circle here. So the last piece is, hey, what happens exactly at -4 and 3? And because this is greater than and equal to, these circles are closed, right? If this had just been greater than without the equal sign, we'd have open circle. So this is a nice visual representation, but then that can be written. Oops, sorry, that's supposed to be an arrow. Right? This is written as x can be less than or equal to -4, which will satisfy any number. Pick -10, plug it in here, and this inequality will work. Why don't you go ahead and try to practice on this last example. So again, solve this, set this equal to 0, figure out the critical points, put those critical points on a number line, test the 3 regions, and then write up the answer. Hit pause, and when you're ready, hit play. And here we go. Here is the answer.